Welcome. Today we're going to talk about solving a series circuit problem. This is from the Principles of Engineering 1.2.4, number 3 on the practice problems. We're going to go through the exact solution for this problem so you can check your answer and learn from it and hopefully use this to do our next set of problems that we're going to work on here for my class. Mr. Hall back here, and we're going to go through solving this series circuit. So they start off by giving us our total voltage. So we're going to go ahead and start by writing that down. Voltage total is equal to 9 volts. Then the next thing they give us is the values of R1, R2, and R3, and those values are 470 ohms, 270 ohms, oh, that's R3 I guess, 270 ohms, and 1.2 kilo ohms. Now we have to make sure when we use this, we convert this and make sure that everything is just in ohms. So we're going to convert that right now, 1200 ohms. Make sure we understand the difference there. All right, so given the total voltage of 9 volts, the next thing they want us to find is, well, I guess directly from the question it says, using the laws of circuit theory, solve for RT, IT, V1, V2, and V3. And we will make sure that we go through those steps. So let's go right into RT. So to find RT, we use Kirchhoff's voltage law and understand that RT is equal to R1 plus R2 plus R3, since this is a series circuit. And so we'll plug that in, and we'll say 470 plus 1200 plus 270, and that's going to give us our total of 1,940 ohms. And there is our RT. There's our answer for RT. Now that we have total voltage and total resistance, we can just use Ohm's law to find our total current. So that'll be our VT divided by RT, which will be 9 volts divided by 1940 ohms, and that will give us an IT of 0.005 amps. That's our IT. Now that we have IT, knowing our rules for a series circuit, we know that IT is equal to I1 is equal to I2 is equal to I3. So using that information, we have R1, R2, and R3, and we figured out IT, which is the equivalent current all the way through. So we can use Ohm's law once again to find V1, V2, and V3. So V1 equals R1 times I1, or I1 times R1, either way. And we can plug that in to say 470 times 0.005, and that will give us our total, or our voltage at R1 of 2.18 volts. V2 equals, I'll write it this way this time, I2 times R2, 0.005 amps times 1200 ohms, and that's going to give us 5.57 volts. V3 equals I3 R3 equals 0.005 amps times 270 ohms, and that will give us 1.25 volts. So there are my answers there, and I can verify that using Kirchhoff's voltage law and say that the total is supposed to be equal to V1 plus V2 plus V3. Well, if I plug those numbers in, 2.18 plus 5.57 plus 1.25, that should give me my total, and it does, of 9 volts, which checks out. So there I have the solution for RT, IT, that's the resistance total, current total, and then our voltage at resistor 1, voltage at resistor 2, and the voltage at resistor 3.